Hi students, this chapter that we're going to study today is about understanding the change of state. You see, in the previous chapter, we saw that matter exists as solid, liquid and gas. But then did you know that solids can be converted to liquids and you know that liquids can be converted to gases again? Let's take a piece of ice for example. You know, when you heat the piece of ice, after some time the ice melts, doesn't it? As you can see, the ice here has been replaced by water. And then if you further keep on heating this water, the temperature of the water keeps on increasing. Finally a stage is reached, you know, when the water starts boiling. Here you can see that the water has been converted to steam. And that is what we're going to study in this chapter. We will try to understand the change of state. We'll understand exactly how a solid turns into a liquid and how a liquid turns into a gas. We'll also understand how a gas turns into a liquid and a liquid turns into a solid. What exactly happens to the particles of matter as these changes take place? That's what we're going to study. So let's begin understanding change of state. Now before we understand exactly how solids turn into liquids and how liquids turn into gases, we must first understand temperature scales. Temperature is generally measured in two units, degree Celsius and Kelvin. We'll understand what degree Celsius means, what Kelvin means, and then we can proceed, because all changes in matter generally involve a certain temperature measurement. For example, we know that water is a solid at 0 degrees Celsius, isn't it? We know that water becomes steam at 100 degrees Celsius. So let's study the temperature scales first. Of course, as we already know, the first temperature scale is the Celsius scale. A person called Andrew Celsius invented this temperature scale. As you already know again, in degrees Celsius, ice becomes water at 0 degrees Celsius and water turns to steam at 100 degrees Celsius. Understood? Of course, you know these things. So, the Celsius scale basically has been developed keeping in mind, the melting of ice and the boiling of water. So these facts have determined, the Celsius scale. When you keep on increasing the temperature from 0 degrees Celsius to 100 degrees Celsius, water keeps getting hotter and hotter. The Kelvin scale, however, is slightly different from the Celsius scale. It was invented by Lord Kelvin. Here's a picture of Lord Kelvin. In the Kelvin scale, ice melts at 273.16 Kelvin, not 0 Kelvin, but 273.16 Kelvin. Similarly, water boils at 373.16 Kelvin. Understood? So these are two values that you simply must remember. Ice melts at 273.16 Kelvin and water boils at 373.16 Kelvin. Why exactly are these features chosen? Why do we say that ice melts at 273.16 Kelvin? Like, isn't that a vague figure, 273? Where did that figure come from? We will learn more about where that figure came from in further classes and not in this class. But to give you a brief idea, we generally think that at 0 Kelvin, the particles of matter stop moving. They are at rest. And so 0 Kelvin is sometimes called absolute zero. And 0 Kelvin is basically 273.16 Kelvin below the melting point of ice. Understood? So that is why this figure has come up. I know this will sound very weird. What kind of absolute zero am I talking about? But don't you worry. For now, all you need to understand is that ice melts at 273 and water boils at 373. One interesting fact here is that we don't write degree Kelvin. We just write Kelvin. So I'll not say, that the temperature outside is 358 degree Kelvin. I'll say the temperature outside is 358 Kelvin. Another interesting fact that you must remember is that change by 1 degree Celsius means change by 1 Kelvin. So the magnitude of 1 Kelvin is the same as the magnitude of 1 degree Celsius. For example, if you take the difference between the boiling point of water and melting point of ice, what's the difference? 373.16 minus 273.16, that is 100 Kelvin. Similarly, Even in the Celsius scale, the difference between the boiling point of water and melting point of ice is 100 degrees Celsius minus 0 degrees Celsius, that is 100 degrees Celsius. So you can see that the temperature difference is 100 Kelvin and it's also 100 degrees Celsius. So change in 1 degree Celsius is basically the change in 1 Kelvin. Understood? So this is again one thing you must remember. Yet another fascinating thing that you must remember is the conversion between degree Celsius and Kelvin. You see, at 0 Kelvin, the temperature in degree Celsius is minus 273.16 degrees Celsius. At 273.16 Kelvin, the temperature is 0 degrees Celsius, and at 373.16 Kelvin, the temperature is 100 degrees Celsius. To convert any temperature, from degree Celsius to Kelvin, the simplest method is simply to add 273 to the temperature in degree Celsius. Understood? I'll repeat it for you. To obtain a value in Kelvin, all you have to do is you have to add 273 to the temperature in degree Celsius. Understood? For example, let us look at 100 degrees Celsius. 100 degrees Celsius is basically 100 plus 273, that is 373 Kelvin. Similarly, 0 degrees Celsius is 0 plus 273, that is again 273 Kelvin. So as you can see, whenever you are given any temperature in degrees Celsius, just add 273 to it and you'll get the temperature in Kelvin. Of course, ideally you should be adding 273.16 to it, isn't it? Because after all, we just learned that 0 degrees Celsius is 273.16. But we generally approximate 273.16 to 273 because in normal calculations it doesn't really matter if you write 273.16 or 273. So just add 273 to get the temperature in Kelvin. Now that we've understood temperature scales, let's solve a problem related to them. It has been found that water has its maximum density at 4 degrees Celsius. At what temperature on the Kelvin scale does water attain its maximum density? What is happening in this question? Well, simple. We are given a temperature, 4 degrees Celsius. We have to convert this temperature to Kelvin. And that is very simple, isn't it? To convert from degree Celsius to Kelvin, we'll simply add 273 to 4 degrees Celsius. And that gives us the value of the temperature in Kelvin as 277 Kelvin. So water has the maximum density at 277 Kelvin. That is our final answer. Okay, so now we're done with the temperature scales. The next thing we're going to study in this chapter is exactly what happens to matter on heating. You see, our chapter is understanding change of state. So let's consider any matter, be it solid, liquid or gas, and let's try to heat it. And let's see exactly what happens when we heat any substance. Let's consider ice, because ice is a quite common substance, right? We find ice in our refrigerator. Now when we heat ice, we see that ice slowly melts and it gets converted into water after some time. We also see that if we keep on heating the water again, air bubbles start escaping from the water and the water starts boiling. That is, the water gets converted into steam. So what do we conclude from this? When we heated ice, it became water. When we heated water, it became steam. What we can conclude is that solids on heating turn into liquids and liquids on heating turn into gases. And that is the first thing that we're going to learn in this chapter. Understood? Ice was a solid. When you heated it, it became a liquid. When you added more heat to the liquid water, it became steam, a gas. So solids turn into liquids, turn into gas on heating. First of all, let's study the conversion from solid state to liquid state in detail. The conversion of solid to liquid is called melting. So melting is the first thing we'll study. The conversion of a solid into its liquid state, as I just said, is known as melting. Melting is sometimes also called fusion. this spelling here, Fusion. As we already know, when we heat ice, ice melts. And just like ice, all the substances we see melt on heating. In fact, even if you heat gold, which is a solid at room temperature, at a very high temperature, gold also melts. And as you can see in this figure, it becomes a liquid.